How does event handling work in Python desktop GUIs? Imagine clicking a button or pressing a key and suddenly your program responds instantly. That magic is thanks to event handling in Python desktop graphical user interface applications. When you create an application with Python, you want it to react to what users do. Event handling is how your program listens for those actions and then responds. It is like setting up a series of traps that trigger specific responses when triggered by user actions or system signals. Python has several frameworks for building desktop applications, such as Tkinter and PyQt. These frameworks use an event-driven model, which means your program waits for events to happen and then reacts. The core of this process is the event loop, which runs continuously inside the application. Think of it as a never-ending cycle that checks if anything has happened, like a mouse click or a key press. When an event occurs, the event loop sends it to the right part of your program for handling. Events can be of many types. For example, mouse events include clicks, double clicks, or moving the mouse. Keyboard events involve pressing or releasing keys. Window events happen when the window is resized, closed, or gains focus. Each event carries details about what exactly happened, like which key was pressed or where the mouse was when clicked. Event handlers are functions you write to tell your program how to respond to specific events. For example, a handler might display a message, change some text, or update the interface. To connect events with handlers, you use binding methods. In TK, you can bind an event to a handler with the bind method. For instance, root, bind, keypress, onKeyPress links any keypress to the function onKeyPress. For buttons, you often assign a function to the command parameter, so clicking the button runs that function. PyQt uses a different system called signals and slots. Widgets emit signals when events happen, like a button emitting a clicked signal. You connect these signals to functions, called slots, which handle the event. When the event occurs, the signal is emitted and the connected slot runs. When an event triggers a handler, it often receives an event object. This object contains details about the event, like the key pressed or mouse position. You can use this information to make your response more specific. For example, if a mouse click occurs at certain coordinates, you can use that data to decide what to do next. Here's a simple example in TK. First, you import the library and create a main window. Then you define functions for key presses and button clicks. You bind the key press event to the window and assign the button a command. When you run the program, pressing any key will print which key was pressed, and clicking the button will print a message. The event loop starts with main loop, which keeps the application running and listening for events. In summary, event handling in Python desktop applications works by setting up an event loop that waits for user actions or system signals. When an event happens, it is sent to a specific function designed to handle it. This system makes your application interactive and responsive, allowing users to engage with it naturally. Starting with simple event bindings, you can build complex behaviors by combining multiple events and GUI components.